get started on lesson 2, deploying Ethernet cabling, overviews, layouts for RJ45, so on and so forth. Let's move forward. At the physical layer, networks are made out of different types of cabling and their connectors and transceivers. These establish direct links between nodes and local segments. At the data link layer, nodes in these segments are given standard means of exchanging data as frames. Remember, we talked earlier in the first chapter about frames, data. So, as they're closely related, networking products often define standards for both physical and data link layers. Remember what we were saying before? Your switches can be capped at certain speeds. Your access points can be capped at certain amounts of devices that can be connected to them. While plenty of other products have been used in the past, many cable networks are now based on Ethernet standards. You guys won't see anything other than Cat5, Cat6, and moving forward, the newer type of standards that we have, fiber optic, so on and so forth. Understanding the options and specifications for Ethernet is essential to building and supporting networks of all sizes. In this topic, we will summarize standards for deploying Ethernet over copper and fiber optic media types and identify the tools and techniques required to deploy Ethernet cabling. So generally go over standards for Ethernet, copper cabling types, fiber optic, which is something new that you guys will be seeing, and we'll be deploying cabling ourselves and learning how to crimp, organize, and ensure that it works, and testing that. Ethernet standards. In this topic, we'll identify components used in Ethernet network implementation. Ethernet dominates the wired LAN product market. Its popularity is largely based on its ease of installation and upgradability. Large and small networks use Ethernet technology to provide both the backbone and end user services. Due to a wide deployment of Ethernet today, you definitely will be required to manage and troubleshoot Ethernet networks as well as cables. Just like myself this morning, I had to redeploy the actual tip for the cable. Megan's desk was smashing the cable up against the wall, and unfortunately it damaged the port. So I had to replace the port itself. And luckily, the previous technician that did the drop left an extra foot inside the wall, so I had enough space to be able to redeploy a tip. And always be courteous to your future technicians. Remember, we have a certain amount of space that we'll discuss on how far you can have between the tip itself and the shield of the cabling. And then we'll also discuss leaving a certain amount of cable in the wall after your drop or your remodel box to ensure that if there's any mishaps, any mess ups, or any feedbacks, you can redeploy that drop without having to rerun the entire cable, which was a definite help this morning. Let's see. All network signaling uses electromagnetic radiation of one type or another. Electromagnetic radiation means transmitting signals as electric current, infrared light, or radio waves. The electromagnetic radiation forms a carrier wave with a given bandwidth of range of frequencies. A signal is transmitted over the wave by modulation and encoding schemes. One example of encoding is transitioning between low and high voltage states in an electrical circuit, making use of a characteristic we call wave amplitude. Let's see, that's still here. Okay, good. These voltage changes can encode digital information, ones and zeros or bits, and we talked about that as far as hexadecimal bits, so on and so forth previously. The more bandwidth available in the media, the greater amount of data that can be encoded. And that's something that we'll hopefully visit later, bandwidth versus speed, because there are certain internet connections that will prefer bandwidth over speed. And you'll have to distinguish the differences for those, like T1, T2 connections, and other types of connections like those. Copper cable. You guys will be familiar with this once you see it here in a bit. Twisted pair. Copper cable is used to transmit electrical signals. The cable between two nodes creates a low voltage electrical circuit between the interfaces and the nodes. There are two main types of connectors for a copper cable, the twisted pair and the coaxial. Nowadays, in most situations, especially in our state, you'll be seeing the coaxial copper connection. Copper cable suffers from high attuition, meaning that the signal quickly loses strength over long links. Twisted pair cable is related to CAT standards. And that's why a lot of the times when you have Comcast or Xfinity Link come in and install a cable, they try to immediately get that cable in from the house and have the shortest distance between the modem and the cable they drop into your house. Fiber optic cable, that's something that's a newer standard that's been being released to residential clients as we see throughout the next coming months. Rio Rancho is getting fiber optic currently with Comcast. Fiber optic cable carries very high frequency radiation in the infrared light part of the electromagnetic spectrum. The light signals are also not susceptible to interference or noise from other sources and less affected by attuition. Consequently, fiber optic cable supports a higher bandwidth over longer links than copper cable. And that's why people are preferring it, but since it's so new, it's a lot more costly. Fiber optic cabling is divided into single mode, SMF, and multi-mode, MMF. And the MMF is categorized by optic mode designations, usually OM1 and OM2, OM3, OM4. Ethernet standards. Over the years, many protocol standards and products have been developed to implement the functions of physical and data link layers of the OSI model. Remember those layers from the first chapter, the 7 layers that we go from physical all the way up to the last layer. Okay, the most important of these are the IEE standards, the Institute of Electrical and Electronics Engineers, 802.3 Ethernet standards. And something that you guys will have to remember about this is this sometimes varies between state. When we did the Bellagio network in Vegas, this was God. That was a whole different lifetime years ago. We were required to run conduit in anything that we did low level voltage. In the state of New Mexico, you're not required to run conduit. So always make sure that you refer to standards and compliance measures per state that you're in. And sometimes it's required per city or county. So you have to be extremely careful when you're doing deployments like this. Ethernet standards provide assurance and network cabling will meet the bandwidth requirements of the application. The standards specify bit rate that should be achieved over different types of media up to supported distance limitations. These Ethernet media specifications are named using 3-part conventions, which is usually referred to X base Y. This describes the bit rate in megabits per second or gigabits per second, the signal mode, baseband or broadband, you'll hear that very common. All mainstream types of Ethernet use baseband transmission, so you will see specifications of the form of X base minus Y. A designator for media type. For example, 10 base T denotes an early implementation that works at 10 megabits per second. It uses baseband signal and runs over twisted copper cabling, a T connection. Not a T1, just a standard T. Media access control and collision domains. Ethernet is a multiple access area network, which means that the available communications capacity is shared between the nodes that are connected to the same media. Media access control, MAC, refers to the method a network technology uses to determine when nodes can communicate on shared media and to deal with possible problems, such as 2 devices attempting to communicate simultaneously. Ethernet uses a contention-based MAC system. Each network node connected to the same media is in the same collision domain. When 2 nodes transmit at the same time, the signals are said to collide and neither signal can reach its destination. This means that they must be resent, reducing available bandwidth. The collisions become more frequent as nodes are added, and consequently, the effective data rate is reduced. Another type of collision that you guys will experience as well is the IP conflict issue. And that's why a lot of times most people will have to set that static IP we were discussing yesterday in your adapter settings. When you have IP conflict issues, you'll see two systems that won't connect to the internet, and sometimes those systems, it'll be an Alexa dot device or an Echo device. It can be a computer conflicting with another user's cell phone device. It could be a lot of things that are causing IP conflict issues. And later on, you'll learn how to determine, looking through either a trace route or a command prompt PowerShell, or even tools like Advanced IP Scanner to see what's out on the network and what is assigned what IP. Okay, so the Ethernet protocol governing contention and media access is called the carrier center. Sorry, it's called the carrier sense multiple access with collision detection, CSMA CD. You'll hear this a lot in Comcast Business or as well as any business ISPs that you deal with. A collision rate is the state when the signal is present on the interface's transmit and receive lines simultaneously. On detecting a collision, the node broadcasts a jam signal. Each node that was attempting to use the media then awaits for a random period that backs off, basically, like a dam, open, shut, before attempting to transmit again. And of course, you guys see an example here, data to transmit, check the network, and ensure that there's transmittable data and there's a preamble. If there's a collision, it decides to wait and then retransmit the data when there's no other data being transmitted. Awesome. The collision detection mechanism means that only half duplex transmission is possible. This means that a node can transmit or receive, but it cannot do both at the same time. In the base 10T wiring topology, each node is cabled to an Ethernet hub, and the hub repeats incoming signals to each connected node. Consequently, each host connected to the same hub is within the same collision domain. And the 10 base T standards from 1990, you are very unlikely to find it deployed on any networks. You're usually going to deal with 100 base or 1,000 base nowadays. Moving on to 100 base. I think most days. Have you seen anything that's less than a gig, Bob, lately? I think it's a gig lately, right?
For what? The
For any standards like that come on a board or any controller nowadays.
Well, yeah, gig is what we're actually going to push as the normal standard.
Yeah.
But
Yeah, I hardly ever see any controllers or anything with 100 base or 10 base anymore.
I can show you one.
Just yeah, I definitely have some at the shop, and I'm getting the team down there to get me some, things I can display and show to the students. But of course, something like this, we're gonna have to go back to XP systems.
Yeah.
Okay, so we have 100 base TX fast Ethernet standard. The fast Ethernet standard uses the same CSMA CD protocol as 10 base T, but with higher frequencies signaling and improved encoding methods, raising the bit rate from 10 megabits per second to 100 megabits per second. 100 base TX refers to fast Ethernet working over Cat5 or better, Cat5e, Cat6, so on and so forth. Twisted pair copper cable with a maximum supported length of 100 meters, 328 feet. So you have to remember that if you're running 100 base 10, 100 base TX cable that's Cat5, you can go a maximum of 328 feet. That doesn't mean 328 feet and then, the connection and the drop, that's literally 328 feet because then you're going to experience packet drops. 100 base 10 TX can be implemented with a hub, but most networks started to replace hubs with switches as a connection point for end systems. The contention-based access method used by hub does not scale to a large number of systems with the same collision domain, where a hub only works only at the physical layer. A switch uses information about the source and destination addresses carried in the layer, two frames, to establish a temporary circuit between two nodes. Unlike a hub, each switch port is a separate collision domain. By eliminating the effect of contention, switches allow for full duplex transmission, so you're not cut to half duplex. And remember that standard terminology just means that you're either going to be running at full speed or half speed. where a node can transmit and receive simultaneously, and each node can use the full 100 megabits per second of the bandwidth for the cable to link to the switch port. To support compatibility with hosts still equipped with 10 megabits per second Ethernet interfaces, Fast Ethernet introduced an auto negotiation protocol to allow a host to choose the highest connected connection parameters, 10 or 100 megabits per second, and half or full duplex. 10 base 10 Ethernet specifies a node should transmit regular electrical pulses when it is not transmitting data to confirm the viability of the link. Fast Ethernet codes 16-bit data packets into the signal, advertising its service capabilities. This is called a fast link pulse. Remember that, a 16-bit data packet into the signal to advertise its service capabilities is a fast link pulse. A node that does not support auto negotiation can be detected by one that doesn't and is sent ordinary link integrity test signals or normal link pulses. Fast Ethernet would not be deployed on new networks, but you may need to maintain it in legacy installations. And if you guys recall that, this is going to be showing you guys yesterday. Give me one moment. The network adapter settings.
Did Jonathan have a question? He had his hand up earlier.
What's up, Jonathan?
He had his hand up, but you were going at it, so like.
So usually in here, guys, in your controller settings that you'll find in your wireless properties, control settings. If you ever have a legacy installation, you have a newer switch, you can actually set bandwidth values in your settings here itself as well. There's different settings that you can take care of that, especially for Ethernet ports, which this won't show you it. No, that's my USB one. See RX and TX enabled. And you could even edit in here IPv4 check offload, checksum offload, and we'll hopefully discuss that later in VLAN IDs. Just in case you guys ever run into a situation that you need to set those settings in the adapter for a computer itself. No question, Jonathan?
I was trying to make sure he got his codes, and I was looking to see if they were given to me or given to you.
Let me see.
Oh, got to go to the tab. It tells me the right tab first. All right.
While you look for those, I'll move forward.
Okay.
And then let me know if you don't find them, and I'll check my email.
Okay.
Let's see. Okay. Gigabit Ethernet standards, guys. Gigabit Ethernet builds on the standards defined for Ethernet and Fast Ethernet to implement rates of 1,000 megabits per second, a gigabit. That's right. Everybody wants that gigabit speed. Usually nowadays, we can end up getting 300 gigabits depending on the service we choose. Okay. Over copper wire, Ethernet, gigabit Ethernet is specified as 1,000 base T, working over Cat5e or better. So remember, if you have Cat5, you're not going to get that full speed of 1,000 megabits per second, a gigabit. Gigabit Ethernet does not support hubs. It is implemented only using switches. And nowadays, you guys won't find hubs unless you're dealing with small businesses. I still myself find hubs and old lawyers' offices and stuff like that. The maximum distance of 100 meters, 328 feet, applies to cabling between the node and the switch port, or between two switch ports. So you could go 328 to one switch and then 328 to another switch. Gigabit Ethernet is mainstream choice for new installations of access networks. That is, cabling to connect client workstations to a local network. So, for instance, a computer to a server, a computer to your file server where you're hosting a Plex server. Any of those examples would work. The main decision would be whether to use copper or fiber optic cable once you get to these speeds. Fiber gives a better upgrade potential in the future, while copper cable is still cheaper to install, and far more hosts are installed with network cards that support copper rather than fiber. And then you still have the ability to run fiber to the business and then convert over to a standard switch. And hopefully we discuss that here soon. If not, I'll give you guys some study material that you can look into that. 10 gigabit Ethernet, 10 GBE multiplies the normal speed of gigabit Ethernet by a factor of 10 because of the higher frequencies required. 10 gigabit Ethernet can only run at reduced distances over unshielded twisted pair. Longer runs require higher categories of cable with some type of shielding. These are also specifications for 40 gigabit per 40 gigabits Ethernet. See if it looks up, it shows you the specification. It does not. You guys don't have the book with you. You'll see there. This is when we start seeing that new Cat 8. A lot of people don't really use Cat 8 unless you have to do some extreme speeds there. And as you can see, as you progress, you get into Cat 8, it drops. And I'll upload that to you guys. Screenshot, give me a second. Snipping tool, where's the chat? Yeah, usually Wall Street, high data centers will use connections like this. And I've seen even companies like UPN, United Private Networks, we partner with them and we deploy their networks. I'm still hearing back from Glenn if we could do a tour of their facility where we deployed fiber optic with United Private Networks. And those speeds that we were getting were up to 900 gigabits per second. I mean, I still go to their parking lot and I connect to their Wi-Fi if I ever need to download a movie and it like that. So, and that's the Carlisle Executive Building right across the street from Wiener Schnitzel on Carlisle in Albuquerque. But once I hear back from them, we might be able to take a class trip to take a look at that. Moving forward. 1040 GBE, gigabit Ethernet, is not deployed in many access networks. Oh, I saw someone typing. Yeah, it'd be awesome. I'll let you guys know about that. There's a couple clients I'll be connecting with to see if we can go do a tour of a couple of their facilities. Okay. 1040 gigabit Ethernet is not deployed in many access networks. As the cost, 1040 gigabit Ethernet compatible network adapters and switch transceivers modules is high. It might be used where a company's business requires very high bandwidth data transfers, such as TV and film production. We work with a lot of cultivation facilities that work with the Department of Agriculture and the New Mexico Regulatory Licensing Division. That's part of a certain industry that I'll leave unsaid. But these companies, like HDR, they require faster fiber optic connections. And it became costly because, of course, Comcast provides you with a fiber optic switch, but you have to get a layer 3 switch to be able to convert the fiber optic to a standard addressable IP address. And that layer 3 switch is the actual switch that spits out the IPs, not the fiber optic switch. The fiber optic switch gets an assigned static IP, which then assigns, all the standard IPs internally in the network. And that's another place that I'll also ask as well.